Florida's artificial reef program is one of the most active in the U.S. A variety of material from rubble to specially designed concrete structures to ships and airplanes have been sunk in more than 2,000 locations throughout the state's coastal waters. Artificial reefs are created to achieve a wide range of goals, from replacing natural reef damaged by environmental degradation, breakwaters to protect coastal lands, and even memorial sites. However, the most popular objectives are improved fishing and scuba diving destinations. These uses boost Florida's tourism industry, especially impacting in the local economies. From the surface, it can seem as an artificial reef are guaranteed to have a positive environmental impact and to increase the amount of fish. In reality, the situation is much more complex. Even though the artificial reefs are populated in short order by many fish, it remains the question whether those fish are merely attracted from other areas or if the artificial reef actually lead to more fish production. Since 1990, the total investment in artificial reef program in Taylor County has been almost $600,000. 90% of that is state funding and around 10% of local government funding. More than 1,300 tons of material deployed. On average, the depth of the artificial reef is 35 foot, but range from 4 to 55 foot. In the last 5 years, have been deployed 450 fish cubes, 120 tetrahedrons of style material, and 61 tons of scrap metal and concrete culverts, covering 2,500 square foot of seafloor only in 2016. Buckeye Reef is located in federal waters of Florida State in the Gulf of Mexico at 20.5 miles offshore of Keaton Beach Marker 1. In this place, FWC performed a site scan in 2017, what shows us the presence of the artificial reef material on sandy and live bottom. The learning objectives of this presentation are to discuss the importance of natural ecosystems improvement through an artificial reef study case, to identify and discuss key factors and variables necessary to assess ecological processes in artificial reefs, to compare the efficiency and different methods to assess ecological processes in artificial reefs, to discuss how the assessment of ecological processes support ecosystem management actions, and to be able to coordinate scientific-based efforts for an artificial reef monitoring program.
The artificial reef material has been deployed since 1995. Only a few actions toward evaluation after the deployment has been done. And the idea in 2018 is to go in the water and assess 18 sites on the Buckeye Reef, evaluate the material structure, and also do some fish census or fish assemblage evaluation, with the final idea to have some information to promote diving or fishing activities in this artificial reef, and also to improve our artificial reef program in the future, get more funding to do more deployments. Objectives of the artificial reef monitoring program, we have to, when we go in the field, we have to fill some forms. The first one is the fish census form, where we have a list of the most common fish found in the artificial reef in the Gulf of Mexico. And then we do two methodologies. One is the stationary, when the diver goes down in the bottom, settles in the bottom, and establish a perimeter of about 15 feet and counts for 5 minutes all the fish that identifies in an area that goes from the bottom to the surface, and take note of the number, specific number, that will help us to have an abundance estimation. After the 5 minutes, we do some roving diving, which is just free diving around the artificial reef, and the diver is taking notes in a second column on the estimated abundance of the fish, which is just if it's a single, few, many, or abundant when it's over 100 animals that the diver is seeing in the bottom.
The same ecological processes apply on natural and artificial reef. However, the physical architecture and complexity of the structure in artificial reef can be adjusted in ways that help the reef propose and affects growth, survival, and other processes of the organisms in the reef. It's probable that developed reefs allow higher concentration of fish to occur relative to the natural reefs. By providing fish shelter, you are concentrating them at a local scale. So the question becomes, is the production associated with the fish assemblage enough to offset the loss due to fishing mortality? If that associated fishing mortality exceeds the production, then the system is operating at a deficit. Other question to consider is whether artificial reef development changes the way fish seek shelter, avoid predation, conserve energy, and access food from areas adjacent to the reef. Fish are adapted to seek out shelter and avoid predation, but what if the configuration of their shelter, specifically the dimension of an artificial reef versus a natural reef, changes the proximity of predators like groupers or red snapper to their prey or their predators? If that's the case, then natural mortality may also be altered because the encounter rate between predator and prey has changes because of the nature of artificial reef development.
All the data that is collected during the artificial reef monitoring program have to be with the artificial reef structure per se, and so we use a different form where we take notes of the divers, who's going down, the max depth, what activities are we going to do, in this case monitoring, photo, video, fish count, material evaluation, and then when we go in the bottom we have to make some take some notes on the dimensions of the reef structure, distance between the artificial reef structure that being deployed, the reef height, the relief, and the status and coverage of the artificial reef structure. That will help us set a baseline for in the future evaluate the progress of marine life colonization and how that helps to attract fish into the artificial reef.
If there is no fishing pressure, we might assume fish to move in a way that they are dispersed within the available habitat. with the densities of fish showing how much suitable space and food are available. Results from some research suggest that while that might be true in an unperturbed system, it is not for reef fish under high fishing pressure. That's because fishermen change their fishing sites in response to catch rates, and this happens faster than the fish naturally redistribute in the reef, even if a fish population is declining. When an artificial reef is built, the availability of the structure fish need is altered. There are studies that suggest that artificial reefs hold initially higher densities of fish than natural reef. However, as the natural and artificial reef structures are different, there is not the same diversity or the same community composition. An artificial reef may lead to new production for small fishes that are highly sedentary and site-attached, as they get their shelter, food, and complete their life cycle essentially in the same place. But the more mobile the fish is, the more it depends on a broader footprint that adjusts the reef for its prey and life stages. For fish such as the groupers and most of the economically valuable fish, it's unlikely that individual reefs are going to subsidize production enough to offset harvest. If it is built relatively few large reefs, it may enhance fishing but would end up with fewer fish, slower growing fish, and a higher fishing mortality. By taking the same reef material and altering the configuration, it can diminish the risk of fishing mortality, increasing survivorship, and enhancing growth rates.